everyone, and thanks for joining us for our fast chat hosted by wordsauto.com. My name is Baite Bezeham. I am a principal analyst for Words, and I'm joined today by Sandeep Krishnagoda, VP of Marketing and Applications for Flash Solutions at Infineon Technologies. Sandeep, thank you for joining me today.
It's my pleasure, Maite. Thank you for having me.
Well, so today we're going to be talking about enabling the next generation of automotive electric and electronic architecture. So let's get started. So I hear that Infineon has recently introduced a new memory device. Can you talk more about this launch?
Absolutely. I mean, we are very excited to launch a new product. It's branded the Semper X1. It's the very first time in the industry we are creating a new memory category around LPDDR flash. It's an innovation where we bring in a new interface like an LPDDR interface in connection jointly with the flash memory. And this provides a host of advantages to our customers, especially as they're migrating towards new vehicle architectures and software-defined vehicles. And you hear LPDDR very much associated with DRAMs, which is a volatile technology. And this is the first time we've mirrored that to a non-volatile technology and create lots of additional value for our customers.
Oh, that's really interesting. I'm just wondering, why is this new innovation needed?
Yeah, I mean, good question, right? You think about the vehicle architectures and what's happening around us. There's a whole push towards electrification of vehicles, and this is absolutely needed for our environment with the decarbonization and digitalization, trend that's happening right now in the industry. And when you imagine, vehicle electrification and the future of vehicles, a lot of it goes down to software-defined vehicles, as in, think of your phones. You constantly get software, you get added features, and that transforms lives and, mobility in general for the emerging population. So for me, it's about how does the future of vehicle electrification look like? And our innovation ties directly into enabling these software-defined vehicles, because, what you have today with the very distributed architecture of lots of multiple ECUs in the car, towards a very centralized high-performance compute architecture, you need new innovations and you need new solutions. And this is where Semper X1, the LPDDR flash memory, really propels in enabling high-performance compute for a full car computer architecture.
Fantastic. I'm just wondering, how are people doing this today without this kind of innovation that you're bringing to the market?
Yeah, so you think about what's happening in two trends, right? One I addressed from an automotive aspect. You see the shift in architecture that's happening, and in order to move that shift, the processors that are actually in these vehicles are migrating to very advanced nodes. And when I say advanced nodes, I'm moving towards like a 5 nanometer, 3 nanometer type of technology nodes that are that need, and these processors have to do that because they need all this computational power. Because, think about a self-driving car, the amount of, computation that's needed in order to do such type of, performance is quite high. And the only way you're going to do that is if you move to advanced nodes. And when you do move to advanced nodes, what used to exist before, where you had embedded non-volatile technology inside these processors or MCUs or MPUs, are is no more an option today. So our customers are looking for what are the alternatives, and there are a few alternatives. Customers can put a lot of SRAM into the processors. They can use an external DRAM to do this, and our solution, which we bring to the market today with this announcement, to use high performance, non-volatile memory directly attached to these processors. So, the advantages of there's pros and cons to all solutions, and the first, putting a lot of SRAM into a processor consumes more die area, is more expensive, more power. The usage of a DRAM versus a volatile technology like a DRAM versus a non-volatile technology like a flash, you see several advantages in the sense it's low power, it's faster, you don't have the amount of restrictions. So in general, the processors get much more instantaneous real-time compute performance than having to copy all the data from a non-volatile memory to a DRAM and then try to execute. And the temperature needs as well is going up in these processors. So I think a combination of all of these different facets of technology, challenges, makes our solution quite attractive to our partners and customers as they are transitioning in their life cycle towards the new zonal architectures in vehicle electrification. We see a lot of growth in this market space.
Yeah, absolutely. And is Infineon partnering with anyone for this new launch?
Yes, indeed. I mean, to bring any new innovation into the market, we have to partner. I mean, there are several tiers in the value chain. As I look at it, we have the traditional OEMs, we have the tier ones that support the OEMs, and then we have the semiconductor suppliers. And for us, Infineon is number one in the automotive market space. And so for us, we see the trends very early in what's happening. And we picked our partners in terms of, the tier ones and the OEMs to see who's migrating in developing a solution that actually addresses a problem. And having worked through the different tiers of, tier ones, chipset partners, as an SoC partners, our memory, we have brought in a solution that, we've been working on this over the last couple of years. We've brought in a solution that is, not just proven on theory, but it's something that we actually have performance benchmarks and real silicon performance in a system to showcase the value of using an LPDDR flash in these applications.
And is it sampling or in production today?
Today, we are sampling the product and will be in production by end of next year. And we expect these products to be in vehicle starting with start of production in 2026.
Fantastic. Sandeep, this has been a great conversation. Thank you very much for your time today. And I hope you enjoyed the discussion with Infineon about enabling the next generation of automotive electric and electronic architecture. Thank you all for watching.
Thank you.